Hi, Tom the Professor here. It's time for another problem. Let's get started. Yes, this problem. I knew at some point we would meet again. Well, let's tackle this problem together and you'll see it's not actually too bad. So start out with, what do we know? We've got a camera that has a weight of 1,250 newtons and a volume of 8.3 times 10 to the minus 2 cubic meters. And what we want to find is what's the tension in the support wire. So since we're dealing with tension in support wire, that leads me to, it's going to be a Newton's first or second law type problem where we're balancing forces and seeing what happens. So the first thing we'll need is a free body diagram. So we've got our camera submerged in the water. Forces acting on that camera, we have the weight pulling downward, of course, and we have the tension in the wire pulling upward. If the camera is not underwater, then and it's not accelerating, it's in equilibrium, then the tension will be equal to the weight. Okay. Since it is underwater, though, there's going to be a third force added here. That will be the buoyant force of it's the pressure due to the pressure difference of the water acting on the surfaces of the camera. Okay, so those are the three forces we need to balance in our equation. And when dealing with balancing forces, the first thing we need to ask is the camera in equilibrium? If it is, then we know that the net force is equal to 0. If it's not in equilibrium, then the net force will be proportional to the acceleration experiencing. Since the camera's not going to be moving in this problem, not going to be accelerating, then yes, it is in equilibrium. Okay, in our net force, we then have to combine these three forces. Let's choose upward to be positive just because, for no real reason. The tension will be one of the forces, plus the buoyant force, which will also be pulling upward, because the pressure on the bottom of the camera is always going to be higher than the pressure on the top of the camera. The buoyant force is always going to be upward. And we will see that later when we discuss how to find that buoyant force. We will maybe see that later when we discuss how to calculate that buoyant force. We may go the simple way to do that. Okay, and then since the weight is pulling downward, we're going to subtract that off. We want to know the tension, so let's solve the equation for the tension. And we get this. Okay, tension is the weight minus the buoyant force. Now the weight is given to us, the tension we're looking for, so we need to figure out how to calculate that buoyant force. Now again, if you wanted to do it the more difficult way, you could calculate that buoyant force based on the pressure difference between the bottom of the camera and the top of the camera and their distance underwater. But in that case, we would need a little bit more information on the volume of the camera rather than just the number. We would need to know the dimensions of the camera so that we can get that the difference in the height. The easier way to calculate the buoyant force is to note that the buoyant force is equal to the weight of the water displaced by the camera. Okay. So the buoyant force is going to be the mass of the water times gravity. Now we're not given any information on the water at all, other than the camera is in the water. So we need to figure out a way to calculate that mass. Well, here's where we sort of go towards, this is Archimedes' principle, dealing with buoyant force. And that will usually lead us to a density type problem. Okay, so if we want to find the mass of an object, it's given by its density times its volume. Okay, so if we want to know the mass of the water, we just have to find the density of the water, which is a given. We're going to use a given value for that. And the volume is going to be the same as the volume of the camera because it's the volume displaced by that camera. Okay, so let's stick that into our buoyant force equation in for the mass, and we get the density of the water times the volume of the water displaced times the acceleration due to gravity. Okay, density of the water, we are going to use 1,000 kilograms per cubic meter, and the volume is going to be the 8.3 times 10 to the minus 2 cubic meters, which was the volume of the camera, And then for gravity, 9.8 meters per second each second, which gives us a buoyant force of 813.4 newtons. Now that we know that, we can throw those numbers back into our possible solution here and calculate the tension. The tension is going to be the weight, the 1,250 newtons, minus the buoyant force we just found, 813.4 newtons, which gives us a value for the tension in the camera, or tension in the cable, of 436.6 newtons. So if we have a scale measuring the tension in the wire, when it's above water, that scale is going to read 1,250 newtons, but once you submerge it, that scale will read 436.6 newtons. And that's everything we need for this problem. Okay. I hope you enjoyed this particular problem. You see, it's not too difficult. Again, if we wanted to do it the tough way, we could, but we would need to know the difference in height between the top of the camera and the bottom of the camera. So we need those dimensions to do it using Bernoulli's equation instead of just an Archimedes principle sort of thing. Right. Thank you for joining me for this one. Make sure you like and subscribe to help support the channel. Get the notification on if you want updates as soon as I post new videos, which, I try to do regularly, but life happens sometimes. If there's a particular problem you want to see me do, leave a comment in the comment section below or hit me up on the social medias at the Facebook and Twitter handle on the screen. Everything I do goes along with my blog, tomteacheспhysics.com, which has some interesting content available for you, along with links to everything except for the YouTube channel. I need to add that to that blog. So all my teacher resources that I have available for other teachers, all the merchandise, which you should go and check out because it's super awesome, and all the other links that I deal with are at the tomteacheспhysics.com. I really appreciate any time you can help and support the channel and everything I try and do to get physics out there to more students. Until next time, I'll see you next time.